Hi, everyone. My name is Marco Abela. I am a product manager here at Dell Technologies working on PowerStore. So what we're going to talk about today is the vSphere, all the vSphere integrations that we have within PowerStore with this session titled VMware DNA at the Heart of a Storage Solution. What we're going to be covering as a part of this is we're going to start with a quick summary of all the awesome vSphere integration that we have within the product. We're going to talk about our vVol implementation, AppsOn, which was talked about in the PowerStore introduction session. So we'll get a little bit more on that, a little bit more of a deep dive and talk about actual customer use cases. And then we'll talk about vSphere awareness within the PowerStore Manager. So as we talked about in the PowerStore introduction session, right, is with PowerStore, we had the benefit of starting with a brand new clean sheet design. So kind of from a product management perspective, we really got to define what the initial building blocks and the DNA of the product was. And one of the pillars, one of the DNA that we really wanted built into the product from the beginning was one of the best integrations with VMware available. So we have integration points with ESXi from a VAI perspective, VASA, vValls, VRO, VRA. Integration with VMware Cloud Foundation from an external storage perspective. And then we also have the AppsOn integration, which is industry unique in being the only purpose-built array with a built-in vSphere hypervisor. But what we're going to deep dive a little bit more in this session is our vVol implementation and AppsOn. So let's start with vValls. So our vVol implementation is very unique. It's again, we built it into the product from the beginning so that it was very, very easy to use, and so that customers could make that leap forward into starting to use vVols. So again, this integration is very, very efficient, and we're seeing customers really starting to take off and use vVols. So one of the first unique things that we did with vValls is that we offer a turnkey vVol setup. There's nothing to configure. You simply just register your vCenter server in the PowerStore Manager, and PowerStore takes care of the rest, allowing vValls to be used instantly. So the VASA provider registration, protocol endpoint creation, storage container creation, the data store creation, all of that happens automatically by the system. So user simply just points the PowerStore Manager to the vCenter, and they are instantly ready to use vValls. Another really interesting and unique thing that we do with our vVol implementation is that we have a stretch storage container, so that as we were showing again before in that the PowerStore overview session, where up to 4 appliances can be added in a cluster. From a vSphere perspective, when using vValls, it's presented to vSphere as a single stretch storage container with the underlying PowerStore resource balancer taking care of the automation as to where to best place workloads. And last, because this question always comes up, with vValls, we support all native PowerStore data services. Next is end-to-end VM visibility. So we have virtual machine visibility that allows users to track capacity utilization, VM compute performance, storage performance, alerting, protection, and even individual vVol granularity that allows users to see things at the individual vVol level within a VM. This is all within the PowerStore Manager, and we have a demo on this shortly after. Last is an SPVM integration. So PowerStore exposes its native storage capabilities to VMware so that a VM admin can configure these VM storage needs according to vCenter. Accordingly from vCenter, PowerStore currently exposes quality of service through SPVM, and we'll have more of these available in releases coming up in the future. Last is we have a managed snapshot integration, which allows users to take snapshots on demand or through a protection policy, which we'll get into in a later session, from the PowerStore manager, which are then displayed in vCenter, or vice versa, where snapshots taken from vSphere are displayed in the PowerStore manager, again, allowing this end-to-end visibility from whichever manager a user selects to use.
Hey, Marco, this is Ray. How does the container persistent volumes show up? I mean, are persistent volumes visible, or is that at maybe the vVol level or the volume level that they can see those sorts of things? I mean, I'm just trying to understand the containerization visibility, I guess.
Yeah, so Ray, I assume the question here is in the context of using, for example, PowerStore with Tanzu, with vSphere Tanzu, right?
Yes.
So if we're talking about Tanzu specifically, right, from a PowerStore perspective, we are perfectly positioned because of this rich VMware integration to be used with Tanzu, right? So with VMware, the CNS integration, the container native storage, that basically relies on kind of a VMware CSI type driver rather than the individual storage array CSI driver. So in that case, it's just using vVols under the covers. So it basically leverages the SPVM policy. So in that case, in the PowerStore manager, it's just visible as an individual vVol visible within this construct.
All right, thanks.
All right, so let's talk about apps on, which is one of the most differentiated features within PowerStore. So as we talked about in the previous session, the PowerStore overview, right? PowerStore is a dual node active-active HA appliance where within each appliance, again, you have two active-active nodes and up to 25 disk drive slots, which can then expand either scale up or scale out from there. The PowerStore OS, which is the brain of PowerStore, runs active-active on each of the two nodes, providing all the storage services that PowerStore provides, which is a container-based software stack. What we do from the apps on perspective is, like I said, each PowerStore appliance is two nodes. A node is a server. What we do is we load the ESXi hypervisor on each of the two nodes and take the PowerStore OS and run it as a virtual machine on each of the two nodes, again, maintaining the same active-active HA capabilities with the same storage capabilities that that PowerStore provides. And what this allows users to do now is that local compute is exposed by the ESXi hypervisor. Local compute is exposed so that users can run VMs directly on the same appliance as storage. So this is ideal for storage-intensive, IO-heavy, data-hungry applications, for infrastructure consolidation use cases, for OEM in a box. And again, it provides the same exact capabilities that the PowerStore storage capabilities that the PowerStore model offers. And we'll get a little bit more into specific use cases shortly.
So, Marco, what level of VMware or vSphere are you running, or ESXi, I guess?
Yeah, so right now we are running the latest version of ESX 6.7, where when as new versions of ESX come out within that main branch, we release them within 30 days. Like if there's a software patch, a security patch, and shortly we will support vSphere 7 in an upcoming release.
Okay, thanks.
Hi, Marco. I have a question, Pietro here. What are, if there are any limitations or, I don't know, compromises in terms of high availability and manageability of virtual machines and application running natively onto PowerStore compared to a native VMware cluster that can use, the VMware clustering capabilities and the underlying storage consolidation that normally is there? Yeah,
hi, Pietro. So I would say there are no limitations there, right? So first of all, everything here is under shared storage. So from a storage perspective, for example, you'll see that we can start, again, as small as a single appliance having two nodes. So there is no limitation there. And second is within this base enclosure, again, the the starting point of appliance is that everything is configured with vSphere HA, so that if a virtual machine fails on one particular node, if there are available resources on the other node, it's simply just a vSphere HA operation that just moves the compute over to the other node. And again, as we talked about in the previous session, now that it also supports scaling out, you now have up to 8 nodes available within a vSphere cluster. So then it could also fail over to any of the other nodes as well.
Okay, so in a way, a PowerStore cluster with apps on activated is more or less like a traditional standard VMware cluster from that management point of view, except that it is primarily a storage cluster.
Exactly. So from the compute perspective, it's all handled by the vSphere capabilities. At the storage perspective, that's where it's the storage OS, the brain of PowerStore. The PowerStore OS, the brain of PowerStore, that handles those that capabilities from the storage perspective.
Thank you.
Was there another question?
Are you going to build some kind of integration with VMware Lifecycle Manager? Because from management perspective, you cannot update ESXi as you usually do in a normal VMware cluster, because you must use a specific build approved by your hardware compatibility list. So you cannot patch as usual the ESX part inside the PowerStore X. Are you going to do something to improve this part of manageability, like integrate with VMware Lifecycle Manager or something similar?
Yeah, ciao, Andrea. So from a vSphere perspective, the actual ESXi hypervisor, we as soon as a new version is available, again within the major version that we support, within 30 days we will have qualified it and support it, because we need to make sure that it's validated and it works appropriately. Once that is done, using regular VMware upgrade tools, BUM or VLCM, it can be upgraded from there. When there's the PowerStore OS, however, when a new PowerStore OS version comes out, like PowerStore 2.0, that's where we then bundle it with a vSphere version as well, and that's where the upgrade is handled a little bit different. But in the future, we are working with VMware to look as to how we can actually, from the VMware side, do an upgrade that also integrates the PowerStore manager. But that is something that is that would be explored in a future release.
Okay, thanks.
All right, so let's talk about, I talked about in the slide before that we take the ESXi hypervisor and we load it on each of the two nodes. It's really not as simple as that. There's a lot of awesome innovation that went on to actually have this solution come out. So the first is that as part of a 3-way NDA with Intel, VMware, and us in Dell Technologies, we leveraged Intel's VMD technology to completely bypass the hypervisor and enable bare metal NVMe performance with full support for plug and play. Now, what I mean by that is because of, again, the regular PowerStore operating model is that you can scale up in single drive increments by adding NVMe drives, and that capacity is automatically available to the PowerStore manager. If you were to do that with a regular ESXi server, in order to recognize that additional capacity, that server would need to be rebooted, which means some type of downtime or maintenance window. As part of this, again, it sticks true to the core PowerStore basics in enabling non-disruptive, flexible scalability. So with that, what this technology allows us to do is, again, add capacity as needed without any type of interruption that's immediately recognized. The second is exclusive and guaranteed resources. So we do a split of resources between what is available in system space, so for the PowerStore OS, and what's available in user space for users to run the user virtual machines. These are exclusive and guaranteed, so there is no trespassing of the two, so that performance is guaranteed between the two. Next is that the PowerStore with apps on, one of the awesome things about it is that it's actually multi-personality. So that apart from allowing VMs to run on the PowerStore appliance as part of this new apps on model, it also simultaneously acts as a traditional SAN in being able to serve storage to servers, external servers via fiber channel and iSCSI. So this allows customers to protect their existing infrastructure spend while helping them to modernize with this new operating model. And last is, as I showed before, is again, we have a very tight and unique vBall integration. So let's get into some of the actual use cases that we see our customers using apps on with. So here's 3 examples of PowerStore with apps on being used for edge and robo deployments in order to consolidate infrastructure. So in these examples, you see 3 customers running 3 to 4 ESX servers and a SAN for a small number of VMs at their robo sites, or for example, in this middle one at a manufacturing plant. AppsOn gives them the ability to consolidate into a single 2U platform with shared storage, rich data services, again, that the PowerStore OS provides, and active HA capabilities, all while allowing them to protect their existing investments made, because again, it also acts as a traditional SAN. Another common sticking point that we're seeing with AppsOn is that it provides customers the ability to standardize on the vSphere hypervisor versus disparate technologies. We're seeing PowerStore complement VxRail, with one customer standardizing, for example, their entire core data center on VxRail and their edge sites, which previously ran anywhere from 3 to 6 ESXi hosts with direct attached storage onto PowerStore with AppsOn. Another customer here is running AppsOn at each of their stores to run their point of sale systems after having suffered an outage previously where they were running local servers with direct attached storage. They chose PowerStore with AppsOn because of the small footprint, the high availability, and it allows their IT team to standardize on vSphere. Touching more on complementing VxRail. So HBL is a bank that standardized on VxRail, but has a use case for storage intensive workloads, which they purchased PowerStore with AppsOn for. Because of the common vSphere layer, it enables them to move workloads between the two as needed. Again, because you share the common hypervisor, so vMotion, you can move things in and out. With those VMs that require more IOPS going to PowerStore. And again, talking about data-intensive workloads, this is a particular customer, a global engineering customer that standardized completely on VxRail. So they have VCF on VxRail, along with plain vanilla VxRail, and this customer needed reliable, high-performing, high-capacity storage to run data-intensive applications with low compute requirements, but with very high capacity and highly available storage. They have 6 VMs that each require 26 terabytes of storage, and running this on VxRail would have required too many additional nodes due to the high capacity requirements. In came PowerStore with AppsOn to complement this environment, providing this workload with the required capacity, all at less than 0.75 milliseconds of latency, enabling their goal to reduce their data center footprint. And last here is the University of Pisa that uses PowerStore with AppsOn as part of an HPC environment, which they use for scientific instrument calibration as part of a COVID-19 investigation. They were looking for high-performance storage that would complement their VMware environment with some local compute in order to reduce footprint while maintaining, again, this high-performance and high-capacity requirements. So in summary, again, what we're seeing for the use cases that's being adopted for is edge and robo, again, due to the small form factor, where you have a dual node HA config with shared storage without the need for a witness and all the PowerStore data services. For data-intensive workloads that have large capacity requirements. And last, we're also seeing PowerStore complementing VxRail with the vSphere standardization being of value for operational simplicity.
Marco, I have a last question, hopefully. In terms of compute capacity, these nodes, these PowerStore nodes, how do they compare with similar VxRail models. I mean, can you? I can understand we focus on storage here, so on capacity and storage capabilities, but can we run more or less the same number of VMs, the same type of VMs that we could run on a similar VxRail, or do we have to, to give up something?
Yeah, so a great question, Pietro. So from an actual like compute perspective of running virtual machines, right? That's where VxRail leads. That's where they scale to. I think it's within a vSphere cluster, at least 64 nodes. So again, that provides a huge amount of compute CPU and memory to run a large number of VMs. From a PowerStore perspective, instead, right, we have up to 8 hosts within nodes within a cluster. So we're really more focused on requirements where the quantity of storage is very large and the number of applications is modest, right? Where the advantage of PowerStore here, or where the use cases that it can go after, is again, with PowerStore you can start with up to six drives in a base enclosure. You can fill that up to 25 drives, and then from there you can continue to add capacity under those same 2 nodes without adding more compute, with up to 3 additional expansion shelves of 25 drives per expansion cell. So it gives you the ability to add a huge amount of additional capacity without needing to add compute.
So we can conclude that PowerStore with apps on is more suitable for specific requirements for storage optimized type of virtual machines rather than general use cases. Okay.
Exactly. Yep. And that's where VxRail shines, is more of the general purpose, or again, use cases that need lots and lots of compute.
And they can complement each other. I see.
Exactly. Yep.
Hey, Marco, can you quote a delta between I/O within the PowerStore cluster for a VM running versus something outside using vVols? I mean, is there a performance boost?
Yeah, so there's not necessarily a performance boost, right? By running everything local, you definitely have some advantage of data locality. But the way also that the PowerStore works in terms of resource dedication is, right now we have a 50-50% resource split. So 50% of resources are available in system space and 50% of resources are available in the user space. So obviously from a max total IOPS perspective, it's about 50% of what the regular PowerStore would do. But in terms of data locality, because everything runs local, you would see some latency improvements there.
All right. I guess it's a mixed bag.
Yeah. So again, I think that the value is it's around the consolidation standpoint. And again, the consolidation and doing it with large capacity requirements.
All right. Thanks.
All right. So last year, what I'm going to go through quickly is the PowerStore is, again, this isn't specific to apps on, but in general with PowerStore, any PowerStore model, the integration we have with the with our vSphere from a PowerStore manager perspective. So creating and managing these VMs on PowerStore with apps on, or again, not if even with regular the PowerStore, it still happens through vCenter, just like any other ESX environment. However, the PowerStore manager is aware of these VMs and offers great visibility of these VMs running on PowerStore, again, either from a compute perspective or from a storage perspective. Users can easily see the capacity and the performance of these particular VMs. And here now I'm clicking into this and I can see all my virtual machines running on PowerStore with information such as the guest OS, CPU, memory count, utilization, and capacity metrics easily visible. I can click into a specific VM and I can see its capacity utilization trending with the ability to zoom into a specific time period, which again is part of a PowerStore manager for other metrics as well. I can also look at the compute utilization and performance for this VM running on PowerStore's local nodes if it's the apps on model. I can take a look at the storage performance, tracking closely the VM storage metrics such as latency, IOPS, and bandwidth for the specific vVols that make up that VM. And if I also want to see the individual vVols that make up that VM, I can see that as well too, with the ability to drive into the specific vVols. So as you can see, PowerStore's integration with VMware is built into its very DNA. So in the interest of time, I'm going to skip the next slide here, and I'm gonna leave it on this. If you want to learn more about AppSon or all the different vSphere integrations that we have with PowerStore, you can go to any of these links. Some of these have been shortened to make them easier. You can learn more about, again, everything that we've done around integrating VMware into the very DNA of this product.
At the beginning, you mentioned also integration with vRealize. It could be easy to think about vRealize operation like a management pack, but there was also vRealize automation integration.
Yeah, so vRealize automation and VRO, they kind of work hand in hand together. So we have a plugin or a pack for VRO. So that it's into VRO and then VRA calls into that. So the two are kind of tightly integrated together, and PowerStore does have a plugin or a pack for VRO.
Okay, good. Thank you.